Hello, physics people. I wanted to get on here and solve and kind of show how to work through the exit ticket from the other day. Most of you have done it at this point, which is great, and I appreciate y'all staying on top of your stuff. Some of you haven't done it yet, but that's fine. That's your decision. And so I wanted to work through each part. This is kind of actually a lengthy problem. It might seem easy, and it is fairly conceptually easy. But just to show you what these should look like, let me just kind of work through it here. So remember, our hot air balloon was moving upward at 10 meters per second. It drops the sandbag out when it's 10 meters above the ground, and they wanted you to sketch velocity versus time, position versus time, and acceleration versus time. So if we do that, I'm just going to give myself a set of axes. So we've got position versus, oh boy, that's ugly. Position, velocity versus time, and then we'll do an acceleration versus time. That one's a little straighter. So with position versus time, if we imagine this whole journey, I'm going to start kind of where they describe. So we're going to start as when we're moving up and we're already 10 meters off the ground. So if we're starting at 10 meters off the ground, I'm starting here at positive 10. This would be a distance in meters. So it starts at 10. And then if we think about it's dropping the sandbag out, the sandbag's not going to just fall straight down. The sandbag has the same velocity as the balloon as they're both rising up together. And so the sandbags actually kind of take a little bit of a parabolic arch. So it's going to kind of continue moving upward, and then it's going to fall down. So it's going to do something more like plop and then splat down onto the ground. The velocity versus time graph is also going to start at 10, which is kind of confusing, but that's because they chose 10 for everything. This being 10 meters per second. And so then after I release it, immediately as it's traveling up towards that highest point, it's slowing down until it reaches a velocity at the highest point of 0. So here's my 0. Then after it reaches that highest point and starts to fall back down to the earth, it's going to start getting a negative velocity. And so it's going to be something like this, a nice linear negative trend line. And that's because the acceleration, the whole time it's in the air, as soon as it leaves the hot air balloon, is the acceleration due to gravity, which is negative 10 meters per second squared. And yeah, it's 9.8, but on the AP test, you'll actually just use 10. They prefer that because it's just easier for everyone. Ooh, that was ugly. That should be, whoa, we're glitching. Should have been meters per second squared. Sorry about that. So my line would be like this, a nice constant negative 10 meters per second squared. This slope, remember you can go back and forth between these graphs. So the slope of a velocity versus time graph gives you acceleration. So this is a nice constant slope of negative 10. And then here, if we take a few slope values, we can see the initial slope here is 10, which corresponds with our 10 here. Then at this highest point, the slope of this line, if I drew a tangent line here, would be 0. Notice that corresponds here with my 0. And then as it comes back downwards, I start gaining a negative slope that becomes very steep, such that when it hits the ground at impact, it's going to have a very large negative velocity. You can see some negative value down here that corresponds with the slope of this line here. So this slope would be a large negative number, which corresponds again here. So hopefully that's helpful. Now, as far as finding the maximum height of the sandbag, it's usually helpful to draw a picture. So like if I have my little hot air balloon, here's my basket, I get thatched. Drop my sandbag out, it's gonna go up, it's gonna come down, then it's gonna splat down into the ground below. I dropped it from a height of 10 meters. We know it's gonna go up a certain height, then it's gonna come back down the full distance to the ground. And so they want to know, what's the maximum height? Well, I know the initial height was 10, and I know it was initially traveling at 10 meters per second upwards. So when you're thinking about your kinematic formulas, we have v equals v sub naught plus at. We have x equals x sub naught plus v sub ot plus 1/2 at squared. And then you have v squared is equal to v sub o squared plus 2a x minus x sub naught. Anytime we do this x minus x sub naught, you can just write that as delta x. So this last one really is just like v squared is equal to v sub o squared plus 2a delta x, final minus initial. So thinking about this, looking at my formulas, if I want to know the height of the sandbag, I have to pick one of these that has distance involved. The only one that really makes sense is going to be the second one, because I don't know anything about what the impact velocity is down here. Since I don't have the impact velocity, I've got to go with the second equation. To get to the second equation, though, we also have to think about time. We don't know anything about the time. And so to find the time, you first have to start with the beginning equation. So thinking about my journey, I know that it's going to take time to go up. It's going to take time to fall all the way down. So we actually have to divide this into sections. The first part of the journey, I would go from 10 meters per second up to the top where it has a velocity of 0 meters per second. So plugging that in here, if I set my final velocity v as 0 meters per second equal to my initial velocity, 10 meters per second, plus the acceleration due to gravity, negative 10 meters per second squared, times t, that you can see we would subtract 10 across, we'd have negative 10 is equal to negative 10 t, which means t would be equal to 1 second. Which means as the sandbag leaves the thing, it's going to take one more second to travel upwards, then it's going to stop. So I know that this height, delta y, takes 1 second. Then it's going to fall all the way down to the ground. So what I need to do next is figure out, okay, how high did it go during this 1 second? Well, as you might imagine, now that I have a time, I can go to my second formula here. So if I do that, I'm just going to do it in the space down here. Just draw a box around these so that they're separate. I'm going to change color as well. Let's do blue. So I'm going to subtract x sub o across, so I can just write it as delta x. So we would have delta x, the change in distance, is equal to v sub o t plus 1/2 at squared. Now, the initial velocity, if I'm thinking about this part where it's going upwards, I labeled it delta y here, delta x here, it doesn't matter. X, y, it's just a distance. Here we're talking vertical, so they're interchangeable. So when I think about this height, the initial speed that the sandbag was traveling was my 10 meters per second. So the change in, I'm going to switch to y now, because it's vertical height. The change in height, distance, is equal to my 10 meters per second times the time I solved was 1 second, plus 1/2 of my acceleration due to gravity, that's negative 10 meters per second squared, times my time again, 1 second squared. Noticing I've got all numbers, I have 10 times 1 plus half times negative 10 times 1 squared is 1, half of negative 10 is negative 5, 10 plus negative 5 would be 5, so delta y would be equal to 5 meters. So that means during the 1 second that it falls out of the balloon, as it's traveling upwards, it's going to travel another 5 meters into the air. Okay, so it was off the ground 10 meters. It goes up to 5 meters more. So then the maximum height has to be 15 meters. Now, they said provide evidence for your claim, and it shouldn't only be equations. This is the equation portion of it. The reasoning, and really all I was looking for from y'all at this point, was it's got to go higher than 10 meters because it had an initial velocity of 10 meters per second, and that is a positive 10 meters per second. So that indicates that the sandbag had to travel upward before it came all the way back down. And we can tell, obviously, the height would be just 5 meters plus 10, as we said, 15 meters. So that's part 2. Now, in doing this, we've actually almost figured out the last part. How long does it take for the sandbag to reach the ground? We already figured out that it's going to take 1 second for it to go up to maximum height. Then all we have to do is figure out how long it's going to take to drop down 15 meters, right? So I would be adding 1 second to whatever this time interval is, t equals question mark. So then to find that time, I'm going to use the second equation here. I'm going to change colors once more. So I'm still using the second equation because I've got a time, I've got a distance, and the nice thing about choosing this highest point, we know the highest point, the velocity is 0. So this v sub o value is actually going to go bye-bye. It's going to disappear. So my height, my delta y, would be equal to, I'm going to rewrite the equation, v sub o t plus 1/2 at squared. The initial velocity we just said, at the highest point, the velocity is 0. So negative 15 meters, because I go from initially 15 to 0. So 0 minus 15 would be negative 15 meters, that's displacement, would be equal to, this whole term goes to 0 because I'm doing 0 meters per second times time, so this goes away, plus 1/2 of my negative 10 meters per second squared times t squared. And that's what I'm solving for, is t. So I would have negative 15 equals negative 5 meters per second squared times t squared. The cool thing here is when I divide across, right, 5 into 15, I would have 3. Notice the units. I'm going to be left with If we divide this over, meters and meters are going to cancel, leaving me with seconds squared. And since I'm dividing, it would actually flip to the numerator. So I would have 3 seconds squared. If you don't speak algebra, then just you can write that out and kind of go slow if you need to. But this is essentially becoming 1 over second squared. So when I divide by -5, divide by -5, this would be meters per second squared. So that's why meters cancels. Second squared, if you're in the denominator of the denominator, it flips to the numerator. So that's why I get 3 seconds squared equals t squared. And if you can't follow that, you can at least see this, that when I square root both sides, oh boy, I gotta erase that, that looks ugly. When I square root both sides, to get t, the square root of 3 we know is, in our calculator, 1.73. So 1.73, and when I do the square root of second squared, I get just seconds. So it takes 1.73 seconds to fall from the highest point all the way down to the ground. So if that's 1.73 seconds, it took 1 second to get up to the highest point, then my total flight time is 2.73 seconds. So that would be the full explanation in terms of equations. In terms of words, it would be the things that we've said. Since the sandbag takes time to travel upward and go to a velocity of 0, then it must take additional time to travel all the way back down to the ground. Also, since they give us easy numbers, you could have even estimated. You could have said it's going to take 1 second for it to slow down from 10 to 0, since I'm accelerating at a constant -10 meters per second squared. Then it must take about 1.5 to 2 seconds to fall the rest of the way back down, since I've traveled above 10 meters. So something like that would be a good word explanation. Hopefully that's helpful and you feel like you can do a basic kinematic problem. On the practice test that you're doing today and tomorrow, this is really just to see where you guys are at in terms of kinematics. Remember, on the AP test, you only have to get half of anything correct in order to pass. If you can get 50% of the multiple choice and 50% of the free response, then you'll easily earn at least a 3, close to a 4. So that's the goal. If you're feeling like none of this is attainable, if you don't feel like you can shoot for 50%, then I would suggest you raise your standards, because I think it's doable. I think you guys can hit half of this and get it all correct. Even if you're not anywhere near 100%, that's totally fine. If you have additional questions, come and see me. Otherwise, good luck on your practice test.